Good afternoon, ladies and gentlemen, and welcome back to question 16 on the 2006 Grade 8 Gauss paper. So question 16 in the diagram, what is the length of BC? So BC is down here, and I noticed that we've got some other numbers, 16, 20, and 5. The other thing that immediately catches my eyes is these right angles. So we've got some right angle triangles. So let's copy our diagram. Oh, I'm still on orange from our reflection question. Copy, we get right angles here, right angle here. I know this is 16, this is 20, and this is 5. Already I think I can work out in my head the answer is going to be 13, but let's go through the motions. Okay, so we have a whole bunch of right angle triangles. ABD and BCD are right angled. And there's a very special property that right angle triangles have. If they look like A, B, C, we know that C squared is equal to A squared plus B squared. So A, B, and C are the lengths of these lines here in our right angle triangle. Well, we've got AD as a hypotenuse, as the longer line. AB is 16. We got 20 there. We don't know what BD is. BD squared plus 16 squared, so plus AB squared. Let's rewrite it this way. 20 squared is AD squared, and AD squared, because it's a right angle triangle, is AB squared plus BD squared, and that's 16 squared plus BD squared. Okay, so now we can work out what BD is. We actually don't need to, because we're just going to square it again to get the hypotenuse here, but let's go through it a little slower. 400, now we can bring over the minus the 16 squared. Again, bust out the calculator if you need to. We're going to get 144 is BD squared. And you can press square root, and you'll see that 12 is equal to BD. So let's add that in. We've worked out 12. Now we got another triangle down here, 5, 12, and BC. Hey, BC is the thing I want. BC squared is going to be BD squared plus DC squared. I just worked out what BD is. So I got 12 squared plus 5 squared. 144 plus 25. No shame in ever using your calculator on these contests. They're allowed. We get 169. If you don't know that's 13 squared, that's all right. But that's the sort of thing that if you're going to keep going on these contests, you'll eventually pick it up, and it's something I suggest people memorize. So BC is 13. So we get our final answer. We'll use the darker blue, 13. Okay. Now, I said earlier on I could see it's 13. And I wasn't doing all these squares and calculating in my head really fast. No, you get to know after doing all these contests a certain while some of the numbers that pop up, especially with right angle triangles. These are called Pythagorean triples. Common ones are 3, 4, 5. You can get a right angle triangle with 3, 4, and 5. 5, 12, 13, that's another very common one. 6, 8, 10, why that's just the 3, 4, 5 with each length doubled. In fact, our 12, 16, and 20, that's just the 3, 4, 5 triangle stretched out 4 times. Okay. Other nice ones, 7, 24, 25, although you usually find that on things like the Pascal and the Cayley, some more advanced papers. What's another good one? One of my favorites, 8, 15, and 17, just because he's a little different. Yeah, and you sort of pick these ones up, and so I could see the 20, the 16, and my brain automatically fills in the gap of, oh, it's going to be 12. 12, 5, brain automatically fills in the gap. Hypotenuse is going to be 13. Okay, so you'll eventually get there too, when you'll just be able to say, oh, it gets this, this, this. I've seen so many of these. Okay, if this is your first one, we made it through. If it's your millionth one, you probably got the 13 faster than I did. Okay, but let's see where 13 is in terms of our answer key. 13, it's the very first one, A. So there we go. So that's question number 16. We got 4 more to go in B part. We'll take a look at question number 12 next.